Breaking news, researchers at the University of Michigan have developed a new battery cell system capable of powering electronic devices such as laptops on the planet of Geonosis.
Is your lightsaber running out of power when you need it? Is your faithful MacBook dying on you prematurely? Introducing the new and improved nickel-cadmium battery. A recently improved old technology, it's more reliable than lithium-ion batteries, and unlike them, does not need an internal computer to monitor its charge. Our new nickel-cadmium batteries are comparably lightweight to their lithium-ion cousins. Battery life is an amazing 20 years! And for a limited time, get a 70% discount for a 5-year extension on your battery life warranty. Restrictions apply. Our durable nylon cells and carbon-carbon composite battery casing allows our product to function well in the harsh conditions of space. Wow, what a difference! Geonosis Tech NICD.
Turn it over to Paula at the University of Michigan to give us the details of what the challenges of designing this system were.
Thanks, Dan. The planet Geonosis is a primarily desert planet with a rocky, mountainous terrain. However, water has been found on its surface, which makes it a possibility for sustainable human life. Geonosis is also susceptible to harsh solar radiation storms and sandstorms. The planet is made up of a molten core and rocky mantle, which forms its rocky desert. Besides all of those relatively extreme weather conditions, Geonosis also experiences flash floods at its carved highland canyons. One of the main difficulties in creating a sustainable environment on this planet is finding a way to power the technology we depend on for everyday life. One of the main things we needed, particularly for research, is our computers and laptops, which allow us to quickly access information, communicate with each other, and perform needed tasks. Our researchers have developed a battery system capable of powering a standard 13-inch MacBook Pro. Obviously, when working in these harsh conditions, there are a few requirements that need to be met. One is durability. We must be able to have a system that can withstand varying temperatures as well as the flash flooding and sandstorms that may occur. We also want an efficient electrical output even at higher temperatures and a system that will resist thermal expansion. Finally, since the materials will need to be brought over to Geonosis, making the system simple and cost-effective in terms of shipping is also a desire.
Thanks, Paula. Now let's head over to Antonia and Chris with the details.
Thanks, Dan. The battery we developed is a combination of a nickel-cadmium battery. We're using a water-based cell with nickel-3 oxide hydroxide positive electrode plates as the cathode, and a cadmium-negative electrode plate as the anode. In addition, we use potassium hydroxide as an alkaline electrolyte. The battery is made by rolling the electric plates into a spiral configuration with a separator material in between. This allows the surface area of the electrode to be maximized, which decreases the internal resistance of the cell, and thus yields a higher discharge current. The potassium hydroxide electrolyte acts only as a charge carrier, and lithium hydroxide is added to the electrolyte to increase the life of the positive electrode. In addition, we used a vented cell design, meaning each cell has a low pressure release valve which releases any generated oxygen and hydrogen gases when the battery is discharged rapidly. This makes the battery safer, lighter weight, and gives it a simpler and more economical structure. Each cell is made of a light and durable polyimide nylon, with multiple nickel-cadmium plates welded together for each electrode inside. A silicone rubber liner serves as the separator, and the top of the cell contains the vent. Large nickel-plated copper studs and thick interconnecting links between each cell allow us to assure minimum effective series resistance for our battery. In addition, we've enclosed the cell in a protective casing, which Chris will elaborate on further.
All right, thanks, Antonia. We have enclosed the nickel-cadmium battery in a protective casing made of a carbon-carbon composite material. This material is both a strong and light material, which allows the internal components of the battery to be protected in the rocky terrain of Geonosis. This casing provides an extra layer of protection, in addition to the steel casing it is already in. The carbon-carbon composite is processed through carbon fiber reinforcement in a matrix of graphite. A step in the processing of this casing, where voids are gradually filled by forcing a carbon-forming gas such as acetylene through the material at a high temperature over the course of several days, allows for the formation of larger graphite crystals, which enhances its properties. Aside from this, chemical vapor infiltration of porous carbon fiber is done, resulting in a complex, hierarchical microstructure that consists of carbon fibers embedded in a porous matrix of pyrolytic carbon. This pyrolytic carbon matrix has a cylindrically layered structure, where each layer has unique nanostructures and mechanical properties, which can be oriented to yield the desirable properties. Carbon-carbon composite is the same material used for the nose cones of intercontinental ballistic missiles, and has a high durability and is well suited to take abuse. In addition, carbon-carbon is known for having ideal structural properties at high temperatures, as well as excellent thermal shock resistance and a low coefficient of thermal expansion. This is ideal for the fluctuating temperatures on the planet Geonosis. The strength of carbon-carbon with unidirectional reinforcement fibers is up to 700 megapascals, which can be retained at temperatures above 2,000 degrees Celsius. Now back to you, Dan.
A special thanks to all our friends at the University of Michigan. I'd like to wish them the best of luck with their new design. Up next, what should you know for your next cocktail party?